Welcome D-Lab everybody. In the shop I have a rare bird. It is a Valco model 1224 with tremotone. A very cool amp. A collector sent it to me. The amp is operational. However, he wants me to go through it, change the caps, give it a clean bill of health so that it can live on for many years to come. So for your viewing pleasure, let's take a look at the amplifier. This is a pretty rare piece, guys. Looks like one of the knobs is not original. They should both be the white stovetop style, but that's really no big deal. It's got the original power cord. Appears to be a bag of some of those old pinky sauruses that fry. That's a good thing because they're all coming out of this amp. Pair of 6x9s, and the output transformer is mounted right on one of the speakers. Flipping around here, I already took out a couple of the screws so we can have easier access. Pop out the speaker here. There she goes. Kind of nice, folds down for easy access. You can get a better shot of those old 6x9s. They actually look a little bit bigger than 6x9s. Maybe they're 6x10s or 7x10s, I'm not sure, but those are original. So up there in the cavity is the amplifier. Appears to be 4 nuts that are on studs. I'll take those off. I'll be able to pull the chassis out and get easy access. It looks like these caps are probably changed with the chassis installed. But I really don't want to turn this into brain surgery. Let's get it out where we can see it and work on it. I've got the chassis pulled out of the cabinet. Speakers are propped up in place because that is actually hardwired onto the chassis. Got to be a little bit cautious when you're working so you don't stress those output transformer cables. Chassis appears to be pretty accessible. You can see all those little pinkies in there. There's an old Ajax cap there. This one here appears to be a no name, and there's a Black Beauty hiding back there. So what I'm going to do, guys, is totally recap it and of course return the old parts to the owner. We're going to go with the Mallory M150 series capacitors for all the coupling, and then the main filter cap will also be changed. The current filter cap appears to be an old Mallory 3-section 10 microfarad at 450. I'm going to leave that in place. We'll probably land a terminal board and hardwire individual caps, and one of those caps should be the bypass cap for the 6V6s, so he'll end up over here somewhere. Alright, so I was incorrect on the 3-section 10 microfarad cap. All 3 sections are actually in the power supply. None of them are used on the cathode of the output tubes. These 6V6s simply have a 200 ohm resistor going to ground to bias them. Okay, so for the fun of it, let's verify what the high voltage is. Like I told you, it has 450 volt caps. There's a high voltage, look at there. This is right off of the 5Y3 rectifier, and we definitely have 450 volts when she initially comes up. So you got to be cautious when you put in new filter caps that you either meet or exceed that voltage on the caps. Otherwise you got some confetti generators waiting for you. I just discovered something I want to point out before I correct it. Remember I said this Black Beauty had been replaced, as well as this Ajax cap. Look at the connection there where the Black Beauty is going. Somebody desoldered it. They wrapped the leads through but forgot to resolder it. I'm surprised that didn't show up on the initial test. Alright, I've got our new filter caps installed. So we have 2 of the sections here taken care of, wired direct to the 5Y3 socket. And then the 3rd section is over here. They actually had a wire going from the old filter cap that went all the way across and up to this terminal board. So this is a convenient location for the 3rd section. Power up the amp. Same deal. Now we got about 470 volts on startup. Remember before we saw around 450. Probably just the difference in the life of that old filter cap, right? May have been leaking a little bit. Down at 350 now. And I'm hearing a little bit of white noise from the speakers. So that's good. Filter caps are replaced. All is well. I want to make sure everything discharges. And then we're going to change out all the coupling caps. Alright, I've got all those Mallory caps installed. Looks nice and pretty. I deliberately left out the death cap because I need to talk to the owner and see if he wants a grounded power cord. But what I'm real interested in at this point is, obviously, will the amp fire up, which it should, but what is the bias on those output tubes? So I'm powering it up right now. In a minute we should see some voltage ramping up on the meter as the 6V6s warm up. Here it comes. I suspect, as with all these old amps, that the bias is way too aggressive because of the difference in line voltage. Alright, so we'll call it 18.5 volts, okay? So we've got 18.5 divided by 200 ohm resistor. That is 92 milliamps, okay? So if I divide that by 2, that's 46 milliamps per tube. On the 6V6s, man, you guys, you'll flame them out, okay? So we're going to have to change the bias resistor and lower that idle current so that the tubes have a chance to survive. Alright, right there is the bias resistor, that big old 200 ohmer, and that is going to pin 8 of both of the 6V6 tubes, right? So we know that we want to lower the current, so we're going to have to up the resistance. So if we do a simple ratio, we had 92 milliamps, let's say that we want to go to 60 milliamps. Okay, there's 1.53, and if you times that by the 200 ohm resistor, it says around 300 ohms. I got my new 300 ohm calculated resistor in there. I'm going to fire it up. See what we have for voltage across that resistor, and check our bias current. Alright, let's just call that 22.5. We'll divide that by 300 now. That's 75 mils divided by 2. So we're still at 37.5 milliamps going through each output tube. In my opinion, that's still too aggressive. So I'm going to bump that value up a little bit more. Alright, I located a nice 360 ohm resistor at 10 watts. I believe that one is going to get us a little more in the ballpark. Sometimes when you calculate, it doesn't come out with what you actually achieve in the real world. Alright, there's 24 volts. We'll just call it 24.4. How's that sound? Divide that by 360. 67 mils, divide that by 2. It's about 33 mils per tube. A lot less aggressive than that, what, 46, 47 mils that we had before. I'm going to go ahead and leave the 360 installed, and we're going to test the amp, because if I keep choking off the bias, we may end up losing performance. I realize. Test on the Valco. At this point, it does not have the grounded cord on, and Tony can already hear the static from that, so we're obviously going to have to put that on. Yeah. So it is operating. Let's check out the tremolo. I just want to make sure everything's cool, and then we'll. Oh, yeah.
Whoa!
Man.
Oh, it's got a nice tremolo.
Yeah.
the speed.
Oh. Well, you're right. It is. So that's
Doesn't
fast
have
speed.
intensity.
No, no intensity. Pretty cool. That's pretty crazy. So I was waiting for the owner to tell me if he wanted a 3-prong cord installed, but after testing the amp, I discovered there was quite a bit of buzz when the guitar was plugged in. Also, if you review the schematic on this Valco amp, you'll see that the center tap of the filament transformer does go to chassis. It did want a ground. So I really don't know how well that worked in the beginning, but now I've got a vintage power cord with a 3-prong ground. You can see the wiring, and this is the old parts. Next thing, I just need to give this guy a cleanup, but the Valco is good to go. Installation of that grounded cord made all the difference in the world, not only for noise, but for safety purposes. So if you have any of these older amps that are running that 2-prong cord and it has a transformer, always ensure that you install a grounded power cord, right? This thing's working great. I love that tremolo.